Hello, Leiden geometry students. Here at the beginning of the year, we're going to start by reviewing some of the algebra that you're going to use in geometry. Some of the stuff you learned in Algebra 1 is more useful and comes up more often in geometry than other things. So we're going to spend the first few days of the year reviewing some of the most important things from algebra that you learned last year that are going to get used in geometry. And the first one we're going to talk about is simplifying expressions. All right, this is an expression. It's just a collection of numbers and letters being added and multiplied together. And the reason I bring this up is a lot of people mix up an expression with an equation. An equation has an equal sign. When we have a problem that involves an equation, we can figure out what x is. But an expression, which is what we'll be dealing with today, all we can do is take the numbers we have and make them a little nicer looking, what we call simplify. Before we can simplify, there's a few vocabulary words that come up in Algebra 1 that we're going to use a lot in the next few minutes here. So we're going to do a fast review. And the first one is a term. A term is just a combination of letters and numbers being multiplied together. A term is broken up into parts. We have the coefficient, the base, and the exponent. You probably remember the exponent. The exponent is saying how many times this number, or this letter in this case, is being multiplied by itself. This is x to the fourth, which means x times x times x times x. And then that's being multiplied by 5. So this term is really 5 times x times x times x. Now you probably remember that, but the one thing that people do tend to forget is this word over here, the coefficient. We're going to use this word a lot in the next few minutes. Coefficient is just the number in front of the variable. So we're going to take some expressions and we're going to perform some simple operations on them, including combining like terms, multiplying, and distributing. Distributing being a type of multiplication. All right, so the first thing we're going to talk about is multiplying terms, or multiplying numbers and variables. So here's going to be our first problem. 3x to the third times 4x to the fifth. I know it looks ugly, but if you remember from Algebra 1, this is actually a very simple problem. There are only two steps when we are multiplying terms. The first step is to multiply the coefficients. That's why we wanted to know that word. The coefficients are the numbers in front, the regular numbers, not the exponents. We have a 3x to the third, 4x to the fifth. We're going to multiply the 3 and the 4. 3 times 4 gives us 12, and that's going to be the coefficient of our answer. The second step is to multiply the variables. Now, the variables here, this x to the third is x times x times x, and x to the fifth is 5x is being multiplied together. Or in other words, it looks like this. In my answer, I'm going to have x with an exponent on it. To figure out what that exponent is, we just add up how many total x's are being multiplied together. In this case, it's going to be 8. Remember from Algebra 1, the shortcut was to simply add these two exponents together. Here, we have a slightly uglier problem now with more than one variable. 3x squared y times 5x y to the third. The first thing you got to remember is our exponents. If there's no exponent here, like right here for the y, if there's no exponent, then it's a 1. Otherwise, we still follow the same rules that we did with the simpler version of this. Step 1, multiply the coefficients. 3 times 5 will give us 15. Then we're going to multiply the variables. X squared times x, remember that's x to the first, we can simply add the exponents. So that'll be x to the third. Y to the first times y to the third will become y to the fourth. That's the whole problem. So here's a problem for you to try. We got 4x squared y to the third times 6x to the fifth y. I want you to try to multiply these together. And the correct answer is 24x to the seventh y to the fourth. If you can do this problem, you are good for now for multiplying terms together. The next skill we're going to talk about is adding terms, what you learned in Algebra 1 as combining like terms. Adding terms, or combining like terms, is one of the things you're most likely to remember very well from Algebra 1. It's not particularly difficult. So I'm going to apologize ahead of time for breaking this down to an analogy that seems fitting for a kindergartner, but it won't last very long. So problems just essentially break down to something like this. If you look out and you see this and I ask you what you saw, you'd say, oh, I see 4 cows. Cow, 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 cow. It's 4 cows. Mathematically, we'd say cow plus cow plus cow plus cow, like this, is equal to 4 cows. This is essentially combining like terms. We're going to take the problems and make them a little bit harder because, as we saw before, we're going to have ones that have different types of terms. Now, In this problem, we run into our first analogy. That's our first problem, but with the analogy should seem pretty obvious. When I add up these cows and pigs, they don't become 5 cow pigs. If the animals are different, we don't group them together. This is not 5 cow pigs. This is 3 cows and 2 pigs. If the animals are different, we don't combine them. Now, mathematically, we're going to drop the pictures in just a few minutes and break this down to simply saying 3c plus 2p. One more picture problem. Here we have pigs, cows, and monkeys. As we add them up, again, as animals are different, we don't combine them together. In this case, we look at our pictures, we have 1 pig, so we'd start with saying pig. If you want to put a 1 in front of it, you can, but if your coefficient is just a 1, you don't need to include it. Next, we look for our next animal. In this case, it's cows. We can count up how many cows we have. Cow plus cow, skip these, plus another cow. That's 3 cows. And finally, add up our 2 monkeys. We have 2 monkeys. Okay, so let's take the pictures out of this and look at this from a math perspective, which the problem would look like this. Okay, and now we're going to add the animals, or in this case, variables that go together. We try to do this alphabetically, so we're going to start with our x's. Your Algebra 1 teacher probably taught you to underline the like terms. For example, 3x minus x. These go together. 3x minus x is like 3 cows minus a cow. That'll give us 2 of them, 2x. We do the same thing with the y's. 2y plus 5y, they are like terms. Add them up and we'll get 7y. This 3z here on the end does not have any like terms, so it doesn't change in any way. We simply have plus 3z at the end. There are a few tricks that people tend to get caught up on when we combine like terms. And here is the first one. This 5x in this problem has nothing to go with it, so the 5x will be just part of the answer. 6y minus 2y, no problem, that's going to be 4y. What about this 4xy? Do I put that with the x's, the y's, both? And the answer is neither. If it's an xy, 2 different variables, that's not the same as x, it's not the same as y. These are cow pigs. You can't add them with the cows or pigs, or some weird mutant offshoot. So this one, since the variables are different, does not count with the other variables. So in this case, we're going to have 5x plus 4y plus 4xy. There's no other animal that has this combination. Just like that is when we have different exponents. Here's almost the same problem, but now it's 4x squared. And just like in the last problem, x squared is not the same as x. It's not the same as y. So it is its own set of terms. It is a different animal. So when I combine my like terms here, 5x by itself, and then 6y minus 2y, and this 4x squared is different, and it just gets thrown on the end. It does not get mixed with the x's or the y's. And that's basically it. If you can do this, you can do most of the combining like terms that we'll deal with here in geometry. So here's a practice problem for you to try. It's kind of big and ugly, but start off by looking at which parts, the letters one at a time, and identifying the like terms. So when answering a problem like this, we try to do this alphabetically. I'm going to start with the a squareds. Here I have 3a squareds. There are no other a squareds in this problem, so my answer is going to start with 3a squared. Next, we go to just letter A. We have 3 terms that end in a. 6a minus 2a plus 3a. 6 minus 2 plus 3 is going to be 7, so we have 7 a's. There's no b's, so we move on to the c's. We have 5c plus 4c, that's 9c, minus 3c will give us 6c. Finally, at the end, this 3ac, there are no terms like it, so it's just going to get tacked on at the end here, plus 3ac. The third way we simplify expressions is with distribution. Now, distribution might be one that you also remember really well from Algebra 1. Again, I'm going to use the animal analogy to explain this. I apologize if it feels a little too easy, but we're going to talk about cows and pigs again for a moment. So if a farmer sells cows and pigs, but doesn't sell them one at a time, he sells a box full of cows and pigs. And in his box, in his package of cows and pigs, there are 5 cows and 2 pigs. So you can't just buy 1 cow. You have to buy 5 cows and 2 pigs. Jamie, she buys 3 packages of them. How many cows will she get and how many pigs will she get? Well, it's not really that hard. She's going to buy 3 packages. Each package has 5 cows. So 3 times 5 will give us 15 cows. For the pigs, each package has 2 pigs, and she buys 3 of them. 3 times 2 will give us 6 pigs. We represent this in math without all the pictures. We write this. Here's the package, 5 cows plus 2 pigs. And she's going to buy 3 of them. It's 3 times this. We show this by saying we're not going to add 5c and 2p. They're not like terms. But each one is going to get multiplied by 3 in what we call distribution. 3 times 5 cows gives us 15 cows, and 3 times 2 pigs gives us 6 pigs. So we distribute the 3 to each of these terms. And we get 15c plus 6p. Here are some samples of some distribution problems. This first one, we're going to multiply 4 times the quantity 3x plus 8, and then 2x times the quantity 5x plus 7. When we say the quantity, we're talking about something in a set of parentheses. So for the first problem, I'm going to do 4 times 3x and 4 times 8. 4 times 3x will give us 12x. 4 times 8 is 32. So we get 12x plus 32. And again, these aren't like terms, so you can't do anything else with them. They just stop right there. Here, the second example has an x being distributed, so we got to remember the rules from multiplying terms. 2x times 5x will give us 10x squared. 2x times 7 will give us 14x. And that's it. That's the ends of both of those problems. All right. Here are a couple of simplifying problems I'm going to ask you to do. Problems 1, 2, and 3 here. You're going to do combine like terms or multiply or distribute. It's up to you to figure out which one is which. And the answers to each of these. In the first problem, 5, we're going to distribute. 5 times 2x, 5 times 8. That's going to give us 10x minus 40. For the second problem, we're looking for our like terms. 4a minus a is 3a. 5b plus 7b is 12b. And this plus 3c gets added on the end. So 3a plus 12b plus 3c. The last problem, we are simply multiplying terms together. 5x to the third times 2x to the sixth. 5 times 2 is 10. X to the third times x to the sixth is x to the ninth. So 10x to the ninth. So here is the last and kind of the challenge problem of the video. You're going to try to simplify this. And in this case, you're going to have to start off by distributing. You distribute first, and then you combine your like terms. However, one thing we had not gone over here is we're going to distribute minus 5 or negative 5 into these two terms. So you do this, negative 5 times 2x and negative 5 times 1. You're going to end up with a minus 10x and a minus 5 at the end. See if you can simplify this. All right, so when you do this, you're going to distribute 2 times x plus 6. You'll get 2x plus 12. And then 4 times x minus 3, you're going to get 4x minus 12. And then the hard part, negative 5 times 2x, you get negative 10x. And negative 5 times 1, you get negative 5. Next, we combine our like terms. 2x plus 4x minus 10x. That's going to give us, negative 4x. 12 minus 12 cancel out. We just have this minus 5 on the end. That's it.